for the correlation and regression, you can just solve this using Excel. So no need to analyze it using manually. But I'll show you the manual way. Okay, so by the word correlation, we're actually talking about correlating or relating things, determining the relationship of two dependent and independent variables, or it could be two independent and one dependent variable. Because if we do already two dependent, meaning two results, it's another method and it's a harder method. So we'll not dig deep on that anymore, okay? Let's dig on one dependent method only. All right? So, diba? This one only, diba? This one itself, it's it's hard to digest. No? So, it's really mathematical. So, because we're talking about quantitative techniques. So, do not mind that, guys. Excel will solve it for you, okay? But basically, it's the summation of the independent and the dependent variable over the square root of the multiplication of the SXX and the SYY. So don't mind that anymore. Excel will solve the R for you. Okay? Diba? Amazing sa Excel. It solves for us. So, there will be actually three scenarios when we talk about correlation. It could be negative correlation. So they say that correlation can be there's still a relationship but negative. Diba? Sana all parang toxic relationship, no? There's a relationship but negative. Why? Because as the X increases, the Y decreases. Yeah, correct. The Y is the dependent. So if the X increases, the Y decreases. So it's a negative relationship. While the positive correlation is if the other increases, the other also increases. So if X increases, Y increases as well. It's a positive correlation. But the no correlation at all, meaning to say there's no relationship at all. They're not related at all. So you might want to check if there's a relationship at all. Diba? So that's the correlation. And that is using scatter diagram. So scatter diagram will solve or show the relationship. Okay? All right. So the computation of R, guys, kato ganing the SXXYY over square root of SXX over SYY. That's actually the R. And the R can be determined in terms of the following. But it will always be ranging to -1 to +1. So if it's from 0 to 0.25, guys, or 0 to -0.25, it's either a strong, weak relationship or weak positive relationship or weak negative relationship. If it's from 0.75 range, 0 to 0.75 range, it's either positive intermediate or negative intermediate. And if it's in between 0.75 to 0.25 to 0.75 rather to siya. And then the 0.75 to 1 or -0.75 to -1, it's either a strong positive relationship or a strong negative relationship. So if it is equal to 1, it's a perfect correlation. They really relate to each other positively or negatively. Gets everyone? So you will understand later what's the purpose of that. Let's have an example. Okay. An article in Journal American Ceramic Society, rapid hot pressing of ultrafine PSZ powders, consider the microstructure of the ultrafine powder, oh my God, of partially stabilized zirconia. I don't even understand this problem. As a function of temperature. The following data was gathered in the table below. So your goal is to compute for the coefficients of correlation and test whether there is a relationship between the porosity and the temperature. What's in porosity? What's porosity? I think it's more on the rustness, no? Or is there a word rustness? Like, will the Or in Bisaya, it's mataya ba? How do you say that in Tagalog? The taya?
Gwen, akin na yung charger ng phone.
Kalawang, yes, correct. So like, will the temperature in degrees Celsius affect the porosity, the level of the porosity of the powder, of the ultrafine powder? All right, so did you get that, guys? Therefore, we have to determine first which one is the dependent and the independent. So which one is the independent? Diba, we discussed already what independent variable is. Yes, correct. This is your independent. All right, independent variable. And the dependent is the porosity because it will depend on the level of the temperature. All right, so you understand that well. So if we are going to draw that into scatter diagram, automatically scatter diagram will show solution. So for example, let's transfer to Excel. There. Almost done. Information overload, guys. How are you so far? Okay, here, Excel is now good. Coping up. Very good. Okay, I'll copy first the given values. Hopefully this will be copied. There you go. So, can you see the screen or not? Can you see the screen?
Yes, folks.
Right. So, therefore, if we automatically compute that using scatter diagram, it actually shows correlation automatically. No need to solve manually, no? So you just have to highlight and then insert a graph, but you choose scatter diagram. Okay, that one. And then you may have to choose to eliminate 0 to 800 because the temperatures do not meet that way. So you can right-click there and then format axis, I think. Yeah, format axis. And then you choose on the units instead of your maximum is 0, you start with 800 perhaps. Or yeah, we can start with 1000. There. So at least it will provide more scatter, no? And then it's still on 20s like that. And then after that, you can actually put R. So right click the buttons, points rather, and then you add data labels. And then you can also add a format data series. And then, oh no, not there. You can go to add trend line. All right. So you click add trend line, and then after that, you can display the R squared. So the R squared will be displayed for you, and even the equation. So and the no, not the intercept, just that one. Okay. So it will now show now the R and the R squared. So see, notice this is our next target to create the Y is equal to AX plus BY. Okay? Oh, AX plus B rather. So the R squared is 0.201 as 2612. 0.2612 to compute for the value of R, which is square root that one. Square root. Diba? Because it's R squared. So that's 0.511. So based on the level, guys, based on the level, what is it in between? 0.25 and 0.75, correct?
Yes.
So what is the judgment for this one? Is it weak, strong, intermediate?
Intermediate.
Intermediate. So somehow you can say that yes, there might be a relationship, but it's intermediate. But you notice that somehow the graph is katag or scattered good siya. So we will still do the testing. Okay, we will still do the test if they are really correlated. All right, so I'll now go back to the slide. So let's check first if they're correlated. So let us now do the testing. Okay. So manually, this is how it is done. All right. So you don't need to, the same, diba? We computed it's 0.55511. It took us a lot of time, but Excel just give that into using add R. Diba, in the scatter diagram. So Excel is really a happy yes, Excel has this one. And then let's now go to hypothesis testing. Diba, I mentioned that hypothesis testing is null and alternative. The null is the status quo. The alternative is the null is the status quo, and the how dito, the HA or alternative is the point that you want to prove. So you don't need to remember that anymore. This is for the manual way, okay? Excel will also solve this one for us, okay? So first step is we state the null and alternative hypothesis. So your goal is to determine if porosity and temperature, diba, do have a relationship. Therefore, your fee here, I don't know how to say that, the P, is it, raw, sorry, that means raw, like that is raw, okay? So the raw is actually stating that temperature and porosity has no significant correlation. Because, diba, I said it's a status quo, like, it doesn't mean anything at all. All right? But what you want to prove is, yes, they have a relationship. So therefore, your symbol is P is not equal to 0, meaning there's a relationship. So the temperature and the porosity has a significant correlation. That's your hypothesis testing. And after that, you choose your level of significance, type of test, sample size, but this is for the manual. Okay? The good thing with Excel is that you just look at the P value. All right? So yeah, let's go now to Excel. Okay. So the technique, guys, is just very simple. You highlight this one, okay? Then you go to data, and then data analysis. Diba, remember, I let you add this in the data analysis tool pack, okay? Data analysis. And then you choose correlation. O, diba? It will solve for us lang yun, okay? You check correlation, okay? And then input range, this is your input range. And then instead of group by columns, they're grouped by rows, right? They're grouped by rows. And then label on the first column. And then your output range, you just put it here. Tineng. Solve. Tineng. So it solved your R automatically. Negative lagi ay ang R. Oh yeah, we cannot determine if it's positive or negative because it was squared. So technically, the correlation will really have to solve for us. So it's a negative relationship. I mean to say, as the temperature increases, the porosity decreases. All right? So there's a negative relationship. Okay. Next, let us compute using another tool. So still data analysis. Instead of correlation, we use regression. So that's the last topic, regression. So you click regression, okay. Your why. So you were asked Now, what is your Y? So your Y is your dependent. Again, which one is the dependent, gani guys? It's the porosity, right? It's the porosity. So highlight everything. And then your X is the temperature. So highlight everything. Okay. And then you check that the first columns are labels. And then output range, let's just use it here. You can add residuals. Okay, and then okay. There you go. Oh. Okay, wait. We have to, it does not cater rows. So we have to transpose this one. Let's just transpose this one first. Okay, transpose. Okay, we will use this one instead of, okay. Not delete for a while. All right, so let's transpose this one first. Hala, I deleted the correlation. Wait, summary out. This one only. Okay, and then, all right, so let's transpose this one first into columns. And then you go back to data solver. And then, not solver, analysis. And then you go to regression. And then okay. And then your Y range are porosity. Okay, careful good, because if your choice of dependent and independent is wrong, automatically your testing is wrong. And then that's for your Y. And then labels are on the first column. And then your output range will be here. So you can add residuals, okay, or normal probability plots as well to show graphs. All right. So there you go. Therefore, still your R is 0.511055. And then your technique now here, see, it computed the SS for you guys. No need to compute for the SSXX, SS. Diba? So ang technique here, guys, is just to look at the p-value. Okay, don't need to look at the F, because the F there, it will have to take a long time to analyze. But the P technique is, if the p-value is less than rather, or equal to the allowed error, or alpha. Usually alpha is 0.05 if not mentioned. Okay. If is less than or equal to 0.05, we reject our HO. We reject our null hypothesis. But if the p-value is greater than or equal to alpha of 0.05, we do not reject HO. Now, in this case, your p-value at the temperature is 0.24416. Is it reject or do not reject?
Do not reject.
Is it greater than or less than 0.
Greater than.
Do not reject. Do not reject. So, di ba, we mentioned that HO is, there is no relationship. Correct?
Yep.
Diba? The HA was, there is a relationship. Because that is what we wanted to solve. Now, it says, do not reject. What does that mean? Meaning to say, the answer is the HO.
Yes, yes.
Did you get that? So, meaning to say, there is no relationship at all. So, even though it says the R has an intermediate relationship, somehow it dictates that there's no relationship at all with regards to temperature and porosity. Maybe the reason is the number of samples are very small, or technically there is no relationship at all and it needs further analysis. Although it will say that there's an intermediate relationship, but it does not declare that there's a relationship. All right. Now, what if there's a relationship? So you will only do the regression, guys, if there is a relationship. Okay, please remember that. Regression is the creation of the formula. So I'll share back the screen. This only happens, okay? The correlation only happens, the regression only happens, guys, if there is a relationship. If not, you stop there because it will not give predictions. Did you get that? You only give predictions if the correlation holds true, that there is a relationship. But if there's no relationship, you cannot predict. Gets? So let's just assume that the one we solved, there was a relationship. So we can compute for the regression model. It's YA plus BX plus E, or A plus BX. The A there is your intercept. The B there is your coefficient of X, the coefficient of your temperature. All right? So, for example, your Y there is income. The A there is the constant. The B there is the relationship to the X. Then the E is the error. All right? So, these are the formula. But again, Excel solved it for us. All right? So, if you have the SXY and the SXX, you can find the B. Okay? But the target here, good, is this one. The Y is equal to A plus BX. This is actually like the slope or the intercept, no? In engineering, it's actually the slope. And the slope will predict, okay? The slope will predict your results if there's a relationship. If not, you don't need to find the equation. All right, so let's go back to Excel. Here. So to compute for the regression, you just look at the intercepts. So this is the coefficients. So the X or the B there is actually this one. So this is the B, right? This is the B. And then the intercept or the A there is the 55.66. Let's confirm. Yeah, correct. See? It actually solved for you, no, in the trend line already. So the negative 0.034 is actually your B. That's why it's paired with the X. And the A there is the intercept. So it's 55.625. So therefore, your regression model is equal to, Y is equal to negative point, or you can start with the A first, A plus BX. So 55.6256 minus 0.0341x. That is now the formula that we'll use for your predictions based on the X. So let's assume you want to compute for the Y. If based on the porosity level. So if it's 1,1, this is the porosity level. So let's say if the porosity level is 1,4, okay, you solve that using this formula. Because you can already predict. So you use this formula. So that's 55.6256 minus 0.30341 times the X of 1,4. So it actually predicts that if the temperature is 1,4, it's 7.9 ang porosity. Naka-gets? No. Gets, everyone? Or information?
Wala na po akong masabi.
But did you get that na the purpose of making the regression model is to predict yun siya. So, with the formula, okay, you just use this one. This is your B and this is your A because your formula is Y is equal to AX plus B. A plus BX. So, your A there is the 55 and your B is the negative. So, in that way, the formula will help you predict. So, what if you will have, say, a temperature in the future of 17? How much will its porosity be? So it will compute. So you can use this one, guys, for predictions. So how much sales based on the number of advertisements released, something like that. But that is, again, used only if there is a relationship. In short, the HO is rejected. All right? Used only if there is a relationship. If not, you cannot predict. Question so far. That's the last one, guys. So don't worry, all of that will be given to you. Okay. So sorry. How much more if we're going to do the manual? No, it's really going to be hard. All right. And then the R squared is just 1 minus SSE, or basically you just square the R. Diba? You don't make it hard. You just square the R provided. And then you don't need to know this one anymore. It's just meeting the sigma. And then they see this is the result of what we did a while ago. A is equal to, this is exchange. Y should be here. So Y is equal to A plus BX. And then this one is for the prediction already. Okay, this is now your simple linear regression model. But that is assuming that there is a relationship.